So on that exponential growth idea, here's a couple practice problems. So the population in 2000, so that's our year zero, was about 200,000, and it's been growing by 8% each year. So growing by 8% immediately tells me that it's exponential growth. Linear means you're adding or subtracting a steady amount. Exponential is reducing or increasing by some set percentage. So it's not that you're adding 5 people, it's that you're adding 5%. So then it says, what corresponds to year zero? So year zero, or n equals 0, means where did we start? We started at the year 2000. So at the year 2000, there were 200,000 people. So that's our initial value. Doesn't have to be year zero, any of that. It's where the problem started. So this gave us our initial value information. So then continuing, we want the explicit formula. So the explicit formula is PO, 1 plus or minus R, depending what it's doing, to the N. We're growing, so it's going to be PN at any time is equal to the initial value, which is the 200,000 people, 1 plus the 8% to the N power. Okay. So to find any year's population based on this growth model, you would do 200,000 times 1.08 to the N. And I'm okay if you leave it either way. You just have to look at what the question's asking. So then using our answer, what year in wise is 2018? So we go 2018 minus 2000. In other words, how many years have passed? It's been 18 total years. So then we want to go ahead and figure out, okay, well, what is the population in 2018? So at the year 18, I'm going to take that explicit formula and put in an 18 for the unit. So make sure that's your exponential. And then if you've done it correctly, it's 7,999, 203.899. But this is asking our actual population. So I'd go for 799,204 people. Okay. And again, always make sure your answers make sense. If they're asking for people, don't tell me 0.899. Okay. And then for this next problem, and you would want to pause these and work through them before you look through the answers, but I'm just going to keep going. So if we have population growing in an exponential growth model, we have a growth rate, and we want to know P1 and P2. Okay. So an exponential growth model, initial population is 14. So let's first just write this out. P1, the next year, would then be 14, 1 plus 0.25. And that would give me my next year, which is 17.5. Here it's okay, because this is a growth model, and we're just going to keep our decimals. P2 would now be that 17.5 growing at 25%. So I'm using the recursive here just to make sure we're getting it. So 21.875, 21.875. So now you kind of have the idea of what we're doing. We're doing that 14 times 1.25, then we did it twice. So for our explicit formula, it's Pn plus Po, 1 plus R, because it's exponential growth to the N. Now, if you have this formula down, what we're going to fill in is the R and the Po each time to get that general formula. So our Pn is already there. So Po was the initial value, which was 14. And then 1 plus R is 1.25 to the N. Okay. And to type that in, it's 14 times 1.25 caret N. So that lumen will take it correctly. Or you could do 14 parenthesis 1.25 caret N. Just depends on how you want to put it in. So then to find P11, we're going to take that N we found and put in 11 for it. So right here, we're going to do 14 times 1.25 to the 11th power, or 11 times. And here we can leave decimals. It even says keep it accurate to at least 1 decimal. So I did it up to 2. Okay, down with this problem, we have the current student population of Orlando. It's decreasing. So that decreasing says that it's going to be 1 minus the 0.126. Another way to think of this is how much is staying each year. So if we do that 1 minus 0.126, that's 0.874. That's the percent of the population that's staying. Okay. All right, so to then look at this, we have to write an exponential growth model for X years. So that growth model is Pn equals Po 1 minus R to the n power. But just note real quick that these are X's, so you would have to type these in as X's if you needed them, but we're actually going to figure out what this gives us. So Po is where we started. We started with 2,800. 1 minus R, we already did, is 0.874. And then what you need to make sure is just make sure you have an X there. So for your exponential growth model, it's 2,800, 0.874 to the X power. And just, again, watch your variables so you're not frustrated when you keep typing them in and it's right, but it's wrong. And then what will the population be in 4 years? And it tells us to round to the nearest student this time. Just use your normal rounding rules. All right, so it would be 2,800, 0.874 to the 4th power. That's where that 4 comes in. So I come up with 1,634 students. And these questions are in your packet, so feel free to be working them out ahead of time. These are just walking through the answers. Okay. So this next one, we have population of Statesville. Let's see what we can grab out of here. In 2010, it was 24,800, and it's growing by 1% each year. So what will it be in 2015? Okay. So our population is growing by a percentage. So we're going to use that P to the N equals PO, 1 plus R to the N. So that's my exponential growth model because it tells me it's growing and it's 1% every year, growing by that increased multiplication. Okay, so now we need to answer the question. PO is our 24,800. 1 plus R, R is that 1%. And now we need to figure out how many N's we're looking at. So to go from 2015, from 2010, 5 years have passed. So we have N equaling 5 here. Okay. So when you put all that in, you get approximately 26,065 people. Right, and then work that again if you're not sure. And then for these final ones, you're writing linear and exponential equations. And each time we're going to be writing the explicit formulas. So for linear, you would want to make sure you know the formula. And that's our PO plus our D, and then whatever our variable is, which is T. And it could be plus or minus. And then for exponential, it's our PO 1 plus or minus R to the T. And this time T is just in place of little n representing our time. So we're looking for one of those for all of them. So first you would want to go through and what are these even going to be? Are they linear or are they exponential? So if I'm increasing by a set 43 every year, that's addition. Every single year I have 43 more. So that's linear. So my initial value for all of these is 990. And then I'm adding 43 students per year. And again, when you're typing in layman, make sure the variables match. They're saying T is going to be your time. So this is 990 plus 43t. If I'm decreasing by 12%, that's repeated multiplication. So this is going to be exponential, and I'm going to do 1 minus r here. So it's going to be 990, and now 12% are gone each time. Then that means 88% are staying. So I'm going to put 0.88t here. Okay. I'm going to go on to D. I'll come back to C. Decreasing by 77. That's a constant minus 77 every time. So that one's linear. So that would be our 990 minus 77t. And then an 8% increase is going to be exponential. So that's going to be your PO, 1 plus, so 1.08t. And then this last one I want to look at, if you're remaining the same, in year 0, you have 990. In year 1, you would have 990. 10 years from now, you have 990. So it's a constant function and just remains 990.